Welcome to today's tutorial. So today we want to talk about moles, calculation of moles for gases at STP. Now let me ask you, what is the gram molecular mass of water? 18, right? Beautiful. What is the gram molecular mass of chlorine gas? 71, right? Beautiful. Now, for gases or for any substance in their gaseous form, doesn't mean whether it's an element, a compound, are you getting me? As long as it is in their gaseous form, their gram molecular mass will occupy a volume of 22.4 dm³. Let's take water for instance. You say that it is 18 gram, right? Now, if I get 10 gram of water, I wouldn't say that the volume that water is occupying is what? 22.4 at STP. Now, let me explain that STP, standard temperature and pressure. Standard temperature mathematically is equal to what? 0 degrees centigrade or 273 Kelvin. Standard because if you are in Nigeria and you measure it, it is the same. If you are in America, it is the same. It is universally what? Acceptable. So is the P there. The P stands for pressure, and the standard pressure is what? 760 millimeter mercury, or you can say it is 1.01 Newton per meter square. Now, if I get chlorine molecule, that is Cl2, right? And I measure 71 gram of chlorine molecules, and you know chlorine at room temperature exists as gas, okay? So it is already in the gaseous form. Now, that 71 gram of chlorine molecule will occupy a volume of 22.4 dm³. Anything that is less than 71 gram, it will not be up to 22.4. And if it is above it, it is not also 22.4. Why? Because the gram molecular mass of chlorine gas is 71. Now, water can exist in 3 states: liquid, solid, and gas. But before you are able to measure water at STP, it must be excited. That means it must be in the gaseous phase, which is what? Steam. Very good. Now, when you measure out the steam of 18 gram, you can say that it is occupying a volume of 22.4 dm³ at STP. Now, let me ask you, if I should measure out 36 gram of water, who can tell me, is it up to 22.4, or would I say it's occupying a volume of 22.4 cm³? No, it is not occupying a volume of 22.4 dm³ at STP, because the molar mass of water is not 36, rather it is what? 18. It doesn't mean whether it is diatomic, monoatomic, polyatomic substance like sulfur 8. Are you getting me? Now, the molar mass is what? 256. So if I should weigh out 256 grams of excited sulfur vapor, will I say that its volume is equal to 22.4 dm³? Yes, because the gram molecular mass of sulfur 8 is 256. Are you getting it? So by definitions, we can say that a mole is that amount of any gaseous substance that occupies a volume of 22.4 dm³ at STP. Beautiful. Now let's go over and do the calculation so that we'll understand it better. Calculate the volume of STP which these gases will occupy. 3.2 gram of oxygen. 3.2 gram of oxygen. Now, oxygen is diatomic. This means that at room temperature, oxygen is already a gas. Are you getting me? It is diatomic. It comes in this form. Are you getting me? Okay, now they say 3.2 gram of oxygen. They have given us the mass already. Don't forget our principles. Make sure you write down the variables. It will help you to navigate and solve the question. Now, this is the mass of what? Oxygen. Now, this oxygen here will help us to calculate the gram molecular mass. This is oxygen, but O here is what? 16. So we can say that our molar mass is equal to 16 times 2. This is 2. Are you getting me? So the molar mass is what? 32 gram per mole. Beautiful. Now, what is remaining is for us to get the mole. Let me give you this simple hint. Each time you are given a question in chemistry to solve and you are given the mass, be it the mass of an element or a compound, just know that you have to find the what? The mole. Are you getting me? Now, we have the mass, we have the molar mass. What next is the what? Mole. Now, I can say mole is equals to mass over molar mass. This is 3.2 over what? 32. And the answer is 0.1 mole. I've gotten the mole. Now, go back to the question. What volume will 0.1 mole occupies at STP? Let me ask you, does 0.1 mole of oxygen occupies a volume of 22.4? No. What mole of oxygen will occupy a volume of 22.4? It is 1 mole. Are you getting me? That is the standard. That is why it is on the board there. Mathematically, 1 mole of any gaseous substance is equals to the gram molecular mass, which is equals to 22.4 dm³. So 1 mole of oxygen gas is equals to 22.4 dm³. Now you ask yourself, if 1 mole is equals to 22.4 dm³, what will 0.1 mole occupy? That is the question. So we say 1 mole is equals to 22.4 and then 0.1 mole is equals to x. What do? We simply do our cross and multiplication. The 1 times x, of course, is equals to x, and 0.1 times 22.4, I'll write it here, 0.1 times 22.4, x is equals to, when you calculate this, you'll be having 2.24 dm³. Beautiful. That is the answer. This means that 1 mole of oxygen gas is occupying a volume of 22.4 dm³, but 0.1 mole of oxygen gas is occupying a volume of 2.24 dm³. So I can say that 0.1 mole of oxygen gas occupies a volume of 2.24 dm³ at STP. Beautiful, beautiful. That is the answer. Now quickly, let's solve this. It is the same method, okay? Now this is what? Sulfate. Like I told you, it can be monoatomic. Are you getting me? Like sodium. Metals are monoatomic. Now gases are diatomic. And then we have elements that exist as polyatomic elements. A typical example is sulfur. Another one is what? Phosphorus. Are you getting me? Now, for sulfate, we can say that M is equals to what? 2.56 grams from our given question. And we can say that our molar mass is equals to, you calculate your molar mass. Sulfur is equals to 32. And how many sulfur? It is 8. Now I can say 32 times 8. This is equals to 256 grams per mole. Please do not forget units. Very, very important when you are solving questions. Now we can go ahead and calculate our mole. Now we say our mole is equals to mass over molar mass. This is equals to 2.56 over 256. And then when you divide this, what will you have? 0.01 mole. Beautiful. So we say 1 mole of sulfate is equals to 22.4 dm³ and 0.01 mole of sulfate is equals to S. Quickly you do your cross and multiplication. So we can say S is equals to 0.01 times 22.4. This will give us 0.224 dm³. Beautiful. That is the answer. 1 mole of sulfur-8 is equals to 22.4. Now, 0.01 is equals to 0.224 dm³. Beautiful. That is the answer. Occupies a volume of 0.22 dm³ as STP. Now, just note that anytime you are given gram, the next thing to find is the what? Mole. Use the mole to relate to the volume if they are asking you about volume. Use the mole to relate, just as we did to Avogadro's number. If they are asking you of the number of molecules or of the number of particles, are you getting me? Now, that will lead us to the third question. If you can see here, this is talking about molecules, Avogadro's number. It is no longer mass, but rather the number of molecules. So you go ahead and check the next video. I'm there already waiting for you. It's time for you to do your part. Please subscribe, like, share, do all those things, you know. I'll come and give you an e-hug. I'm good, Ijeoma. I'll see you in my next class. Bye.